So the Nth Root Test also tests for absolute convergence. Our terms have to be non-negative. Uh, and what it is we do look at the limit as n goes to infinity of the nth root of the terms. If that limit is less than 1, series converges. If the limit is greater than 1, series diverges. And if the limit equals 1, it's inconclusive. We have to use another test. This is very similar to the ratio test. Uh, it's really nice to use if you have something really ugly raised to the nth power, to be able to not worry about that nth power. So if I have the series where n is going from 1 to infinity of n over 2n minus 1 raised to the n, I could do the ratio tests, but I want to kind of show you the nth root test here. So I'd be looking at the limit as n goes to infinity. I can, like the ratio test, use the trick of let's put absolute values to make this forced to be positive of the nth root of n over 2n minus 1 raised to the n. Well, the nth root cancels the nth power. So this leaves me with the limit as n goes to infinity of the absolute value of n over 2n minus 1. This is much easier algebra than the ratio test because we get rid of that nth power. But it's kind of really only nice if everything is being raised to the nth power. If I have things that are not being raised to the nth power, the nth root test algebra gets a little bit more complicated. So I can, because the top goes to infinity and the bottom goes to infinity, I could use L'Hopital's rule. Because n is going to infinity, I'm going to use n behavior models. So it's n over 2n, which is 1/2. And that is less than 1. So the series converges by the nth root test.